Okay, so in this video we're going to start chapter 11. We left off on chapter 7 and we are starting in on chapter 11 and skipping 8, 9, and 10. Okay, so up here I have two springs that are hanging from a crossbar, and I have just sort of conveniently arranged it so that there's these little red markers on the springs that are currently exactly 1 meter off of the ground, so I can just put my meter stick on the ground and I can measure how far those springs have stretched. So what I'm going to do is I'm going to take a 200 gram mass and attach it to that spring. I'm going to take a 200 gram mass and I'm going to attach it to that spring, and you're going to see that there's a difference. And so what is that difference? Well, it's not all that hard to understand. One spring is stiffer than the other spring. So this spring right here is stiffer than this spring. So if we sort of throw this up here, we see that this spring here, the stiff spring, is out to 13 centimeters. So I'm going to say 200 grams and 13 centimeters. And then on this one, I'm going to say that 200 grams brings us to about 30 centimeters. So 200 grams and 30 centimeters. Okay, so let's so we know that there's different springs have different stiffnesses, and that's actually going to be the basis for this thing called Hooke's law. And what I want to do is I want to sort of throw this on here and say, okay, let's look at that spring. And that spring, if I put 100 grams on it, it's going to stretch, it's like 15.3 centimeters. And now let's sort of add 300 grams onto it. Hang on, I might have just moved that a little bit. Let me just check. I don't think I did. We're still good. I'm going to put 300 grams on there. 300 grams is going to take me down to 45.3 centimeters. So that's going to be 300 grams. And now I'm not going to put 400 grams on it, and the reason why I'm not going to put 400 grams on it is because, one, it would go out of the frame of the shop, but two, is that springs are only elastic over a certain range, and if you stretch them out too much, then you end up just permanently bending the metal and they don't go back to shape, and then you've ruined your spring. Okay. But this one's a little bit stiffer, so I can go 200 grams on this one, and I can go 300 grams, and 300 grams brings me to about 20 centimeters. And I can go 400 grams. 400 grams brings me to about 27 centimeters. And then finally, because this is a stiffer spring, we're going to throw 500 gram on there, and we're going to come up with I'm going to call it 34 centimeters. Okay, now one of the things that you've probably already noticed is that these things have a tendency to bounce up and down like that. Okay, and so what we want to do is we want to measure how long it takes for those things to bounce up and down like that. So I'm going to count, and I'm going to measure how long it takes. I don't want to put 500 grams on there. I want to put my 400 on there. And actually, I don't think I'm even going to use that one at all. I like this spring a little bit better, and so I'm going to start putting stuff on this spring. Okay. Stop that one so it's less distracting. And we're going to go up and down. And we're going to measure that. We're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to measure, it took basically exactly 8 seconds. I got 7.99. I'll call that 8 seconds. So 100 grams was 8 seconds. Now, what's going to happen if we put a 200 gram mass on there? If we put a 200 gram mass on there, well, is it going to go faster, slower, or stay the same? Well, let's see. Okay, so I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to get 11.16 seconds for 200 grams. Okay, and so I think that's where I want to leave that, and then in the next video we're going to go and we're going to look at some equations, and we're going to crunch some numbers on how that all works.